Yeah, then comes this question. It says that a bus at Park Station sounds its siren before it departs. Hauta runs towards the bus at a velocity of 5.4 meters per second. She detects the frequency of 440 Hz. Okay. Then the question says that calculate the frequency of sound emitted by the siren. First of all, we are looking for the frequency of the source. Okay. But what else do we have? We have velocity of the listener, which is 5.4. Okay. What else do we know? Frequency heard by the listener, which is 404 40 Hz. Okay. What else do we know? We are going to take our velocity of sound as 340 meters per second. So that's the information we have. But we also know the velocity of the source. And the velocity of the source is 0 because the bus was stationary. So with this information, what do we do? We have our equation. The equation is FL is equal to V plus or minus VL over V plus or minus Vs into Fs. Okay, then what is next? Next is to assess whether it's approach or away. So Hauta was running towards, so it's approach. And what does approach come with? The equation becomes FL is equal to V plus VL over V minus Vs into Fs. I hope everybody knows that approach plus is up and minus is below, and away is the reverse of this. So what do? We substitute. In substituting, we have FL, which is 440. Okay, and velocity of sound is known, 340, and plus velocity of the listener, which is 5.4 over 340 minus velocity of the source, which is 0, all this one into frequency of the source, which we don't know. So this is what we get when we simplify. And from here, what are we going to get? We are going to get 440, giving you 1.01588 Fs. So our Fs is going to be 440 over this. And what you get out of that is going to be our frequency of the source. So that is what we get. 433.12 Hz. So then comes this question. It says that Calculate the wavelength of sound detected by the bus driver. Okay. For wavelength, we know the formula is going to be V is equal to F lambda. Okay. But what do we know? We know V is 340 meters per second. That's the speed of sound. Okay. We know F, the frequency which is heard by the driver. We calculated it before. It was 433.12 hertz. Okay, and we are looking for wavelength, lambda. So what do? We substitute in. You have V, which is 340. Okay, you have frequency, which is 433.12 lambda. Okay, so in other words, our lambda is going to be 340 over 433.12. What you get there is going to be our wavelength in meters. So that is what we get, 0.785 meters. Yeah, so comes this question. It says, how to increase the speed as she approaches the park station. State what happens to each below. You choose from increase, decrease, or remain the same. Okay, what happens to the wavelength she detects? First of all, you have to know that she's approaching and she's increasing the speed. So what happens, what happens to the frequency under the circumstance when you are approaching and you increase the speed? The frequency increases. So if frequency increases and frequency is inversely proportional to wavelength, so wavelength will decrease. And with that, I would like to thank you for your time. This channel is PSSB, Physical Sciences Silver Bullet. Don't forget to subscribe, to comment, to share, and also to like. We need to tell you that PSSB handles Physical Sciences grade 12, 11, and 10, and also Natural Sciences grade 8 and 9. We advise you to use our playlist so that you can sort out the material which belongs to you. With that, I would like to say bye-bye. See you next time.